All right, group, we will get started here. We'll start off a little slow just to make sure anybody that's struggling will have time to get on before we actually get into some good stuff. So we'll just go through, again, a few of the beginning slides and do some introductions and talk a little bit about the format if you've never been on one of our Thursday webcasts. So everybody obviously on here knows what we will be covering today. We'll be covering surfacing and ISDX. And essentially, it's tips and tricks. We'll show some creation. So for those of you that are actually doing surfacing work, hopefully you can pick up a few ideas and things that will help you out. For those of you that are new to surfacing, it'll kind of give you some of the concepts and principles of what you're getting into, because all of us know that are doing surfacing work at this time. Essentially, it is a different animal than dealing with the just straight cuts and rounds and those type of things. It's a different train of thought. Okay. If you do have any questions, please feel free to ask them in the question and answer, or I shouldn't say question and answer, but down here I should say in the questions portion of it. Once I am done with all of my presentations, I will answer any possible questions that I can fit in the time frame that we have allowed it at the end of class. So my nose is a little stuffy today, so hopefully I'm not sniffing too bad as we go through this thing. So also, for those of you that haven't been on before and have never used go to meeting or go to webinar, if you pick that little orange arrow right there, it actually will collapse your go to meeting screen. And you can fly it back out just so you have enough room to see everything that's going on. So be aware of that. It makes it a little bit easier for you to see some of the things that'll be going on today. And remember, questions will be answered at the end of the session. All right, just a little bit about myself. I am Ben Givhan. I work for CDT. It's a Barry-Wehmiller company. We are a value-added reseller of PTC, and quickly what that means is if you think of it as PTC is Ford and we're the Ford dealership, we are now the largest value-added reseller in North America. We have not only offices but training centers in all of the places that you see down below. We are in the process of expanding quickly. We are buying other VARs and absorbing other VARs, so it's a good time for CDT and Barry-Wehmiller as a company. We're expanding and successful in some of the things we do. We are only a PTC products, solutions reseller, so we don't dabble in any of the other CAD stuff. So we have AEs and engineering and sales for everything from the very base Creo stuff all the way out to all of your windshield products, Arbortext, and MathCAD, and whatever it may be. Okay? So our training, we do, again, like you see below, have the certified training centers in those areas. One thing that's a little bit unique about us is we don't cancel classes if you have one person that wants to sign up for class. A lot of times if you go look on the PTC website, if you don't get 5 of them, you don't get 5 students, they will cancel on you. We kind of pride ourselves on our training model. We like to establish the relationships with customers. We think we do a really good job at it. And so if there's anything that you guys need as far as training, you can feel free to contact me with my information at the end of the web session that I'll show you. Or also, if you go to the link down below, you will be able to contact one of our admins or one of us, and we'll be able to help you out. Also, last thing about that is that if you find or would like to take a specific training class and it is not on the list at the time, on the schedule at the time, please don't hesitate to call us. Usually we are more than happy to manipulate the schedule a little bit, move some things around, and if we could help you out and get the class that you want on the schedule, we will gladly do it. Okay. So a little bit about myself. Before we get started, we do have a few questions. Some quick questions that we'd like you to answer. So Sarah, who kind of puts these together and helps me out, and helps us out, I should say, will have you answer those questions. So Sarah, are you ready?
Yes, I am. Here we go.
Okay, go ahead.
Okay. comes the first one. Okay, we'll go to the next one. You got 15 to 30 seconds to answer these.
Okay.
Everybody's fast today.
That's a good thing.
Okay, next one. Alrighty. Back to you.
All right, thank you so much. So I was kind of watching those questions as they were being asked. So it looks like we have a good mix of users, not only a lot of different versions of software. We have some guys that are all the way, at least from the 2 to 4 wildfire range, all the way up to Creo 2. And then also looks like we have a good mix of users using and also not using the ISDX tool. Okay, so some of the stuff that we will do today obviously will be based on that. Just because you see the ISDX tool at the bottom of this doesn't mean you're not going to get at least a good idea of what this is. Honestly, I'll probably introduce this more towards the boundary blend idea right up around here. I just kind of blend this stuff together, even though you see it at the bottom. We'll use it at that point in time. Okay. So here is the agenda that we will run through. Kind of look at this, and this will be fairly fluid, to be honest with you. We'll concentrate on some more areas than others, but we will start out with what I consider to be the absolute most important thing. That's a little dramatic, but one of the most important things that you will ever have to deal with when you come and start dealing with surfacing. And a lot of times you will not find too much information about this out here, and it is the concept of accuracy. Okay, so really, and I'll show you an example of this here in just a second, but really there are two types of accuracies that exist within the software. And the way that I try to show this is that I actually show this usually on a blackboard. And so what I did was I just went in and grabbed a little paint right here, and it helps me describe accuracy a little bit better. Okay, so what accuracy really is, when it comes down to it, is that accuracy is a product of this. Is that if I take a surface, something like this, and then I want to connect it and merge it on to a surface, something like this, accuracy is what ProEngineer uses to calculate how close these two surfaces are actually touching. And where it comes into very, very big play at is that I might be able to merge these two surfaces together, but because of the value of my accuracy, there still might be gaps. So the merge will go, but there will be gaps. And where it will really burn you at is that when you get to going and doing solidifications, or you're trying to create solids, or you're trying to create some type of thickets. So even though you have some type of merge and it looks like everything is all knitted together, if you have a large accuracy value, you will still have gaps in this area. Okay, and if you haven't noticed, for anybody out there that's a sheet metal guy, even at one point in time, and I'll show you this on the slide here, at one point in time, and even now I should say, that the default accuracy that ProEngineer comes in is something called a relative accuracy, and they're starting to switch that now to where even sheet metal parts are now the sheet metal templates start out in something called absolute accuracy, and I'll show you that as soon as we get back to our slides. Okay, now what you'll see here, okay, is that again there are two different types of accuracy. It's relative accuracy, which is the Creo Creo default. Okay, I'll show you what it means when it says based on the size of your part, and you should not repeat, should not be using this. Okay, you should not be using this. The type of accuracy and the value of the accuracy that you should be using is what is called absolute. Now, the only way that you can use absolute accuracy is that if you turn it on with this config option. So enable absolute accuracy is set to yes. Once you have that, you then can control accuracy in two different ways, the value of accuracy. By default, if you look down below, the default of the accuracy, and it doesn't make a difference what type, is this value right here. And you should be, at all point in times, when you're doing surfacing work, should be having this value right here. Really what it comes down to is the amount of math work that Creo/Pro-E puts into calculating all the surfaces and things that you put together. Okay, this is a config.pro option that can be set. You also can set it up in your setup of your part. If it's in Wildfire 2 through 4, it's in the setup. If it's in Wildfire 5 in the Creo, it's under the model properties page that you can go set that up. Okay. Now, let's talk about a little bit about the difference between these two, and you'll kind of see where this becomes an issue in some cases. All right. So the way that first of all, the default accuracy, the relative accuracy is calculated is that, and I'll just do something simple, guys. Here, nobody make fun of my drawings here. Is that, let's say that I have a part, it's just a cylindrical part. Now that's not a good example, but for this, it makes a little bit of sense here. Okay, and so what happens is if I have this cylindrical part, to figure out accuracy when ProEngineer is in a relative accuracy, it is relative to the part size. So what happens is if I have a part that looks like this, ProEngineer will draw a box, a 3D box over this part in something about like that. And then what it does, it'll drive essentially a line from here to here. And what this value is right here is a percentage of that line. Okay? So whatever the percentage of this line is happens to be the accuracy of your part. And so what happens is the larger the parts that you have, the more gaps and open spaces that you have in your parts as you are designing them with surfaces. Now, one of the major reasons that PTC did this, and honestly I've seen grumblings about them removing this, is that a long time ago when computers weren't nearly as powerful, is that when you created much larger parts, the more math and work that they had to do, the longer it took to regenerate some of those parts. So the more features and more surfacing and the larger the parts, is that they dumbed down the part so it made it easier for some of this regeneration stuff. Well, now in 2013, we all know that computers are much more powerful, have much more calculating capabilities and all those type of things that go around it, is that really, essentially, relative accuracy has become a dead concept. So you should be working in absolute. This is how relative is being calculated, and again, you should be working in absolute. Now, few things about this, very important, okay, is that, first of all, and I'll come back to this here in just a second, but first of all, is that if I open up a part, okay, and I'm just going to open up a part, we'll just mold to this part, and we'll come back to this a little bit later, is that under File, Prepare, and Model Properties, if you start a part in relative accuracy, it doesn't make a difference whether you turn on the absolute accuracy or whether you set that value, that will not automatically change all of your parts. And the reason is that if anybody's on here has ever tried to change from a relative accuracy to an absolute accuracy, you find that sometimes you will get regeneration failures on your features that you have created, because all of a sudden now when you're now doing this much more math work, that all of a sudden the feature that you created cannot be built. Okay, so the idea is to model an absolute accuracy from the beginning. Okay, so for instance, if I come in, I say I now want a new part, and what you'll notice is because of my config options, is that when I go down to model properties is that I am in absolute accuracy. Here is the value, and if I pick it, there it is. Enter a value. Here's the value. Okay. So this is a very, very, very important. I can't stress how many very important part of dealing with accuracy and doing this within surfacing work. Okay. So if there are any questions about that, I will get to those a little bit later on. I'll answer those as many as I can, and see what I can come up with. Okay. All right, let's go ahead and shut this down. Okay, so kind of going back here to the PowerPoint. Let's go back to the agenda. So this is more of a discussion point than anything else. When I walk into some customers, I find that there is more experienced surfacing users kind of have this concept in their head. When you're new to surfacing, this becomes kind of an area that you open up in your brain, and you're all about surfacing. One thing that I try to stress to the users that I'm working with, their classes that I'm teaching, is that surfacing should be a last resort. It is much more complicated in its thought process, and I shouldn't say complicated, but much more detailed in its thought process, and that if any point in time you can build most things in solids, but then the very few details that you need to put in, you want to do it in surfacing, that really should be the thought process into doing surfacing work. There's very few times that you should be doing entire models out of surfacing work. If you break down your models, a lot of the times that you will find is that a lot of the things could be done in solids, which, you know, extrude here or revolve here, and then the details and some of the curvature, surface curvatures that you have, right, will be done and should be done in surfacing. So it's something to keep in mind, that when you are going through and doing surfacing work, that always, as much as possible, try to make solid models, or at least solid portions of it, until you are forced into the surfacing realm. You will find that your surfacing, and a lot of the surfacing work that you do, and I was a victim of this when I did a lot of design work in my past jobs, that I would do all my models in surfacing, and my model trees would be, you couldn't scroll through the things. They would be nothing but curves and merges and surfaces and solidifies and merges and more surfaces and more curves and curves and curves and curves, and these things would be forever. When if I just kind of sat back and looked at it, I probably could have did 25 to 30% of my features with solids, and then from that point went into my surfacing, and it would have made it much easier to deal with. Also, what I found, the more surfacing and curve and merging and those type of solidify work, is that when you go into regeneration failure towards the top of your model tree, anybody that's ever noticed this, you have a domino effect of failures that you get into, and it just kind of rolls on you, and you'll sit there for a good part of the time fixing failures, especially when you have a lot of curves and boundary blends that you're creating. If you were to create some solids, sometimes you get out of those situations. So this is more of a talking point than anything else, but again, if at any point in time you get into some surfacing situations, as much as possible, use solids until you are forced to get into surfacing situations. Okay. All right, so the solidify stuff, okay? Obviously, the idea is to start out and create surfaces, but from there, you are either creating full solids, or you're creating some type of thickens. Just a few tips about some of this stuff. So I'll kind of go in and go through what I mean by solidify. Essentially, there's just a few different ways to solidify and some tips and tricks behind it. So the first model that I'll bring up here, let's get this up, is, let's go ahead and close this guy down. We'll close this one down, and I will open up spotted surf. Let's do this one first. We'll also open up this one right here, and then we'll also open up this guy right here. Okay, now let's first start out with solidify add. Okay, here's solidify add. Essentially, one thing to realize about this is, first of all, there was essentially just some solids that were done here. One thing that I will show you about this, if you've never seen something like this before, is that this is a pretty straightforward surface. I will turn off my shading just so you guys can see that. is that I have a true surface right here, and then I also have a surface right here, and then we'll solidify this. But the concept of solidify is where I take a enclosed quilt, which in this case is this guy right here, and then I will take an open quilt, and then I will solidify them. Now, in most cases, whenever I'm doing my solidifies here, I'll just make sure that I get to quilts, I'll pick it and say, I want to solidify or create a solid out of this quilt. And what you'll see is all of a sudden now I will take that quilt and I will turn it into a solid, right? There's my solid. You see now that I get rid of my purple and orange lines in, what is it, in Wildfire 5, I think it's purple and green, and in Wildfire 4, I think it's pink and purple, right? The different coloring schemes that you will see from one to the next, okay, as far as open or closed quilts. But I just have a closed quilt that I just solidify, and now all of a sudden I have mass with this object. Now, what's important about it is this part of it right here, okay? What I have is a quilt, okay? And this quilt is actually open-ended. It is not closed on this end. And what's I found sometimes is that users would always try to adapt essentially the bottom of this quilt to go along to the top surface of these parts. But what you have to realize is that you actually don't have to do that. And so if I come back and turn on my shading, okay, here is my quilt. You know what? Let's make this. Let me take 2 seconds just so that this looks a little bit. There it is. There it is. There's my quilt. Okay, here's my quilt. And so what I'm going to do is solidify this quilt. But notice how it's open-ended. And so the rule is that even though this is an open-ended quilt, if I pick this quilt and say solidify, it will allow me to add material even though it's open-ended as long as the ends of the parts or the ends of that surface are totally engulfed into this solid. So even though it was open-ended, all I had to do was drive this surface down into that solid, did not have to close it off, and then I could go ahead and just solidify it. And so as long as that edge is totally touching this top surface or totally down into this or totally down into the solid itself, is that it will solidify. Now in this case it's fairly simple. You could just put a flat surface on the bottom. But if this was a little bit more complicated, some jagged edges on the bottom for whatever reason, you do not have to fill this in. As long as it's down into the surface, into the solid, or at least touching it 100%, you have the ability to do something like that. Okay. So, there is the idea. Just a little simple stuff about creating solids right there. Okay. Also, same situations. When you come to this guy right here, again, I have a surface that's buried right there, right? Here's my surface that you see right here. If I go ahead and pick that surface, there it is, and I say I now want to solidify, instead of adding material, notice how I also can remove material. And again, the surface isn't sticking out any farther than what the part is. It's just make sure that it is touching in this spot right here. And again, I can remove material just like I can add material. So it just makes a way where you're not building as much geometry as what you have done if you didn't realize this works. It just makes it a little bit easier to kind of deal with something like this. Okay. Also, another way to add and remove material using solids, right? There's our remove material, is that if you come in and use this function, okay, I have a surface right here, just a boundary blended surface, right? I also have a solid that exists. If you haven't ever used this command, this is called the replace command. And what I can do is pick the top of this solid, and if underneath the offset command it's kind of hidden, you will find something called replace. Okay, here's the replace. And if I say I want to replace this top surface with this quilt, it will essentially extend up solids to the quilt, and then also at the same time remove solids. So you can obviously, extend up where you're adding, or totally remove, but it'll also do both of them. And I have replaced that entire top surface just by creating what is called, in this case, a boundary blend, and then added material on this side and remove material on this side. And so again, it's just a solid, right? It's just a solid, very simple solid shape. One quilt right here with some sketched curves to create the quilt, and then I replaced it instead of doing a much more surfacing work trying to create that and then trying to create the sides in the middle. Again, it could create much more work. So just a few concepts around solidifying and adding and removing material and the replace command, and hopefully that gives you a little bit more ammo when you're going to do some of those types of things. All right, we will move on to the boundary blend use. Okay, boundary blend. I also throw some of the ISDX tool within boundary blend. For those of you that haven't used the boundary blend tool before, let's go ahead and close some of this down. I'll kind of explain a little bit about boundary blend, and then we'll get into it from that point. So the idea of boundary blend is where I want to create a surface that is built from, like it says, boundaries that exist, okay? And so there are a number of different situations that you can get into with boundary blends. Essentially, I want to create a surface from this surface to this surface using edge and edge, and you can do that. I'll get into the three edge surface, which is a little bit more complicated as far as concepts, or can be complicated as far as concepts. We'll get into the boundary blend surface where we're blending it from these 4 outside shapes, but we're also using some internal curves. And then the last one we'll do here is we'll go from this shape to this shape, and then also we'll do some control point work in this idea right here. Okay? So here is my boundary blend tool. Now, I will let you know when I get into the style tool. The style tool is the ISDX portion of or the ISDX portion, the add-on or the advanced surfacing. All of this stuff that we'll be doing right now is all out of the base package, and so we'll be going into boundary blend. Okay, so here is boundary blend, and what boundary blend does is that I blend the surface from this shape, I hold the control button to that shape. Okay, now in simple form, all we're doing is blending from this shape to this shape right here. Okay, now what you have the ability to do is, once you create something like this, is to control essentially approach conditions. So what I can do is right click and go tangent, excuse me guys, and at the bottom I can right click and say I want to create a tangency, and now I have this tangent surface. Let's turn off the spin center so I can spin where I want to. I have now this surface. The only problem is when I'm going from this surface to this surface, you're kind of at the mercy of what the system gives you as far as length of tangency, and you don't have as much control. There's a little bit of things you can do, but you don't have nearly as much control. Okay, and so what you also have the ability to do in the boundary blend tool is to go from 1 to 1 to make essentially a 2-edge boundary. You also can make your own curves to control outside shape. Now, this is creating my own definition of what this side curvature and also shape of this surface should be. And I can do that through coming in and saying I want to create my own curve. Okay, it's called curve through points. Now, if I pick curve through points, I'm going to pick this point and that point, and by default, what will give me here is a point, or essentially is a straight line. Okay, and at that point in time, what I can do is say I now want to control tangency. Okay, and I want to control tangency, and this is a little bit different of an interface in Creo 2 than what it is in Wildfire 5, but I'll say I want to make it tangent to that edge. Okay, and I'll say I want that to go this way, and then I'll come down and say, hey, I want to control tangency on this end, and I now want to pick this edge. Okay, and so what I get for the most part is pretty much the exact same curve from here to here, or from here to here, that I got when I did that surface. But what I can do is come into options and do something called tweak. And what tweak does is allow me to manipulate this curve by dragging and pushing on this curve. Okay, and so what I'm going to do is I'm going to say I want to come in and add a point right about there. And now what I want to do is move this point. Now the way that I usually do this is that I will define this curve right here in some type of defined plane. And the reason I do that is because if I take this point and if I drag it essentially to my left, there's nothing stopping that point from diving away from the screen. And so sometimes you might think you did something right until you turn your model this way, and then all of a sudden this point and this curve is now hanging way down in space. So what I will usually do and say I want to define a plane. The plane that I'm going to select, I'll go ahead and say I want to define it in this specific plane somewhere right about there. And then now when I drag back and forth, okay, I'm only dragging in that plane, and you notice that it didn't drag away from me because this is my defined plane, right? And so again, it's like using a sketching plane, right? We're defining a sketching plane as far as what the movement is. So here's my first one. There, see how I now have a little bit more of a belly to the curve that I have. We'll say okay. I will now also create one on the other side, and just for time's sake, we'll create a very simple one. I'll say curve, right? Here's 3 points. I'll pick. I'll control tangency at the end. We'll flip it so it comes out. I'll control tangency at the end. There it is. And now when I create my boundary blend, I now have defined what my tangency needs to look like or curve needs to look like. So in this case, I'll say boundary blend. Now, the way that boundary blends are defined is they're defined in directions. So what I'm saying here is I'm defining the boundary blend here and here, and this takes care of curvature this way. Okay, here's curvature that way, here's curvature that way. I will then right-click and say in my second direction, I will now want to control curvature from this guy and that guy, and now this controls curvature. Let's back up here so we can see this. There it is. Curvature this way, okay? And now I have my boundary blended surface. Okay, there it is. We'll make sure that it's tangent. Make sure that it's tangent, even though it should be because of our curves. And now here's the surface that I just put in. So quite a bit different from just picking 2 objects and then wanting to control this that way, all right? Now, while we're here, I'm also going to do this with the ISDX tool. So one thing that I really like about the ISDX tool, and we'll go ahead and delete this here, is that I believe, in my opinion, that curve creation is much more flexible, much easier to handle when you're doing something like this in the ISDX tool, much easier to define, and also the options that you have with it are nice, okay? And so what I'm going to do is I'm going to get into the style tool. The style tool is your ISDX tool or your add-on advanced surfacing. So what you can do in the ISDX tool is not only create surfaces, but create curves. There are plenty of times when I want to create my own curves. Even if I'm not going to create a surface, I will use the curve creation tool in the ISDX tool just to build my outer boundaries because I like the way it works, okay? And so what I'm going to do is something fairly the same, okay? I'm going to come in and say, I want to create a curve. Now, when you create a curve in the ISDX tool, you have essentially a 3D curve, or what is called a free curve. You have a planar curve, which is a 2D curve, and then you can drop a curve on a surface just as far as just picking points on the surface, and it drops a curve on a surface. And so what I'm going to do here is I'm going to say, I want to create a curve, and I'm going to pick this surface, and I'm going to pick right about there, okay? Now, what's interesting about this is notice how it did that, okay? So if anybody's ever done this and they've done this right here, you have to kind of understand how this works. And so let me back out and let me do it again. And so I'm going to say, I want to create a curve, but this time I'm going to hold the shift button. And I say, I want to hold the shift button there, and I'm going to hold the shift button here. And notice how now it's actually connected onto the surface. So when I'm creating this curve, holding the shift button essentially attaches the ends of your curves onto objects. And in this case, I attach it onto the surface. Now, since we've established this curve right here, once I essentially establish the curve, at this point in time, I can come in and edit the properties of this curve. So I'll say I want to edit the properties of the curve with curve edit. And now I come in and say, all right, I'm going to hold the shift, and now I'm attaching. Let me zoom up on this. But now I'm attached. Either I'm attached onto the surface with the square, or I'm attached onto the edge with the circle. And so I'll come out and attach it right here. There we are. Come out to the end. I'm now attached on to the edge. I'll come over here, hold the shift button. We'll drag it to the edge. I'll put it out to the end, and there we are. Now, once we do that right there, okay, I'll say I'm going to pick on the end, and now this is what makes ISDX very unique. If I pick on the end, I can right-click on this little drag handle right here, and here's everything that I possibly can do essentially with that curve. So I'll say I want it tangent to this edge right here. And then I have the ability to control the amount of tangency by dragging this drag handle right here. If I go to the end, there's my handle. I'll right-click on it and say I want it tangent. And again, I can control the amount or less amount of tangency that I have by dragging the drag handle. If I was attached onto the surface, I could right-click on and say surface tangent or surface curvature. And again, it just gives you a little bit more freedom about this, okay? Also, if I pick on this, if you go into your tangency, you come over here, you have length of tangency and a lot of different options. Some of this stuff I understand, some of this stuff I don't, okay? But essentially the length of tangency that you get. So I like the ISDX surface creation tool. You have much more control that you have in these two. And again, we'll do something fairly simple here just to do it on this other side. I'll say curve. I'll go from this point to this point. There we are. I'll edit that curve. Right. We'll pick it. I'll say I want it to be tangent. Actually, we'll make it surface tangent. We'll come to the bottom. We'll make it surface tangent. There we are. And even though it kind of gives us a goofy result, we'll kind of pull that around there just a little bit like that. Right. Now, also, one thing while we're on this side, okay, if I come in here, I can right-click on this curve and say I want to add a point, or in this case, a midpoint. And now as I drag, you can see I drag this this curve quite a bit differently from this point. Also, what's really unique about the ISDX tool is that if I pick this 4 views, notice how now I can manipulate it, but only in the appropriate view. So notice how I drag this out. At this point in time, I'm only dragging back and forth right here. You can see it move from essentially a front view back and forth, but where you don't see it move is from the side view, okay? So as I'm dragging back and forth, you can see in the side view that that point is staying in the appropriate spot. So I can drag it back and forth. I can see it in the 4 views, so I can see how it is moving appropriately. If I drag it up and down or back and forth here, right, we see that it's not moving in the bottom right hand, or excuse me, the bottom left hand corner. But again, it's a matter of just picking in the view and moving it freehand that way, okay? Also notice if I go to my point, you can put in X, Y, and Z coordinates if you want to. So those are the X, Y, and Z coordinates of that specific point. So again, a lot of different things. There's a lot of different stuff you can do with this. I'll try to keep it as simple as possible so we can make it through some of our other stuff that we have to get through the day. Now, creating a surface. Creating a surface in ISDX tool is a matter of just saying surface. I had this one pre-picked. All I have to do is hold the control button at this point in time. I'll pick this guy, that guy, this one. Notice how I did not have to pick them in a specific order. And at the end, there is my surface that I had to create, okay? Last thing about this, last thing in ISDX, is that because it is promoted as the freeform tool, you have the ability to do things what are called surface edits. And I don't remember if this is in like Wildfire 4 in the ISDX tool. I think they released this and put this in ISDX a little bit later. But what I can do here is say I want to create a surface edit. And what happens is it'll create essentially a grid on your surface. And from here, what you can do is push and pull your surface by modifying the grid and dragging the grid around. So I can come in and put these 2 little humps in my surface, say OK, and now I've created 2 little nubbies in my surface. So you can manipulate and pull different portions of that surface using the surface edit function in the ISDX tool. And let's say we didn't like that. All I have to do is right click on this little surface edit right here and say delete, and they go back bye-bye, okay? So kind of an introduction to some of the differences and the freeform concepts within the ISDX tool and what it's capable of. So quite a bit different than what you see in the basic tools. All right, time frame. We're at good time. Okay, so boundary blend. Let's get back to the boundary blend. The boundary blend is out of the base package. You can create boundary blend surfaces in between 3 curves. So curve, hold the control button, and curve is your first set. And then I will right-click and say second set or second direction and pick this one. One of the rules I always try to follow with this is that what you'll find here, let's solidify this just to make it so we can see it. There it is. That's our final result right there. Is that it is very important that there is a straight line in between essentially a straight edge in between these, because what happens is if there is an arc in any form right here, it will try to drive that arc all the way down into the bottom, and what will happen is you'll have a little bitty hump all the way down. So instead of having this nice straight smooth surface, you'll have this big hump, and it'll try to make it all the way down to the bottom. And yes, you can create a surface from that, but what happens is when you go to solidify or thicken that, it goes down the toilet quickly, okay? So something that I picked up over the years is that if you have a straight line right here, this works much, much better, not for the surface creation, but for when you go to solidify or thicken that, so all of a sudden you don't have this weird geometry in the very driving it to the corner, and you have to deal with that. So creating a boundary blend between 3 edges, pick, your second direction happens to be the top. Now, this is creating a boundary blend, and we'll also do control points here. I have the ability to create a boundary blend surface between this curve, set of curves, and this one. Now, one thing to be aware of is this, is that notice how Pro Engineers, not Creo, essentially doesn't have any concept of surface flow. Okay, if you've ever noticed this, it doesn't ever do a very good job of surface flow. What happens is wherever there is a break from one set of curves to the next, it creates a surface patch, but it doesn't align those surface patches. And so you notice how kind of this you should really be going from this arc to this arc, but that shape is kind of out of whack. What you can do is you can control this with something called what are called control points, okay? And so if I get into my control points, I can say I want to define control points. And what I'm going to do is just line up essentially these arcs. So I'm going to say from this point to that point is how I want the patches to drive. And from this point to this point is how I want the patches to drive. Notice how much more of a blend, the appropriate blend I have. So I'll go from here to here. I'll go from this guy to this one, from here to that point, from this point to that point, and again from over here, from here to there, and again from there to there. And so when I'm done, I now have controlled essentially the blend much, much better, right? I don't have an example of this, but if I had a curve, if everybody can imagine a curve like this with a whole bunch of breakpoints and a straight line at the bottom, you could essentially drive all of this curvature into a corner if you wanted to. So all I have to do is have breakpoints up here, and in this straight curve that I have on the bottom right here, you can actually drive curvature to individual datum points if you want to, or you could break that line or that curve how many ever times for surface patches to match. You actually can drive curvature from natural breakpoints in the curve to datum points also if you want to, if you've never accomplished that, okay? So a few different things you can do. A little bit about the boundary blend tool. We essentially did this idea over here in this one, but different types of boundary blends and how they work, okay? So hopefully that gives you a little insight on boundary blend and a little bit about the ISDX tool. All right, what do we got next? We covered a little bit about 2D and 3D curve creation, so that was all kind of done right here. Merge functions. This is very important. There are 2 different types of merges. If you haven't ever noticed this, here's my merges. Okay, what you will find is that by default, is that, and I'll show this to you here, but let me go ahead and I'm going to pick this quilt, and I'll show you by default what happens here. And I'll pick this quilt, and I say I want to merge. Okay. If you haven't ever looked at this, under the options button, you have something called intersect and join. Okay, intersect and join. And by default, every merge that you do will be an intersect merge, but that's not right all the time. And for most cases, when you have fairly simple merging ideas, leaving everything at an intersect is perfectly fine. But what you will find is that there are situations where you will want to make sure that you set it to a join when it is a join type of merge. Now, what are the differences? Okay, the differences is that this is a join merge and this is an intersect merge. What happens is if I have 2 surfaces that are sharing common edges, they are sharing a common edge, this is a join type of merge. I always try to apply the appropriate merging setting at any point in time. If you've ever created a merge and you get a geometry check that says the merge was successful, but you created tiny surfaces or tiny edges, it's because you did not use the appropriate merging function. And what happens is the merge is okay, but when you go to solidify or thicken that, it all goes downhill quick. Okay, so this is a merge. This is a join merge. This guy right here is a intersect merge. And what happens is when you get a true intersect merge, notice how it's in intersect. It gives you options on what sides to keep. So in this case, it's saying, hey, and if you can't see this, it kind of shows it to you. You can see it by the arrow. But I'm going to say I want the down and I want the inside, and then here is the shape that I get. This is an intersection or an intersection type merge. This is a join type merge. I can't stress how important it is to make sure that you apply the appropriate one. Not for the simple stuff, but when you get into more complicated merges, this kicks you in the butt a little bit later on. Okay, so a little bit about merges and how those can affect you. All right, last thing we'll do here, and I'll do this fairly quickly, is that essentially surfaces, kind of like what we talked about before, is that you only use surfaces when you essentially come down when you have to do it. Here's an example of using surfaces to create some rounds. Okay, what I have here is a round, and this round was created as essentially a solid round if I edit the definition of it. Now, what happens is that I want to apply a round, and if I go back up here, let me do this here real quick. So if I go back up, is that I have these edges that I want to apply a round on. But what happens is if the round can't do this, how do I get an appropriate round on here? And so what you can do is that here's my round. I kept out those edges. But what you can do, so if you haven't ever done this, if you go into your options, you can create these as a surface. Okay. Now, by default, it gives me this little push, right? This little additional on. If you hit the create the end surfaces, it creates a cap for you automatically. So it created the cap for me. And now what I can do here is that now that I have this round, it is a surface at this point in time, but we need to kind of fill in this shape. Okay. So what I'm going to do is merge, or essentially trim out. I'm going to trim out this area and put my own rendition of what the round should look like. So I'll go ahead and say I want to pick this quilt. There it is. I'm going to trim that quilt. I'm going to trim it off to this guy right here. And what we're going to do is we're going to trim this thing, and so it keeps both pieces. Okay, we're going to keep both pieces. I want to here. Give me just a second. Let me do that again. There it is. I will say trim. We'll trim it here. There it is. I want to keep both sides. Where's my keep both sides at? There it is. There we are. Okay, so I'll keep both sides. There we are. There it is. Now we have kind of a separate one. I'll pick this guy. I'll trim it off at this one right here. We'll keep this side. And now we've created our gap. Okay, and so from here, what I can do is there are some curves that I've already created here and here, right here and here. I'll just unhide those. They're just, drawn on curves. You can put them 2D curves, whatever it may be. We'll unhide those. I'll use my boundary blend tool to create this. I'll say boundary blend here, and here is my first direction. And my second direction, it's here and that guy. There we are. I now can go in and merge these together. I'll say quilts, pick, pick, and pick, and I'll merge all of these together. It is a join. And now I can pick those guys and say solidify. I'll add in geometry, and now I have a true, if we hide all this stuff, there it is, okay. I now have a true solid round that I put in by essentially creating my own surface geometry, some based off the original round tool, some of my own that now fits into this area, okay. Again, doesn't fit all situations, but it makes it kind of nice when you can't build some of those rounds and you need to go in and create your own when you're having trouble with it. Okay. All right. So a lot of talking, that I just went through. I'll save the last 10 minutes for some questions. I knew there were some questions popping up. I'll try to answer these. We will cut it off at 12 o'clock. I will put this up here. If I don't get to a question that you have, or if you do have some more questions, feel free to email me those questions at this email address right here, and I'll try to get those answered, okay? Okay. Okay, here we go. Okay, so we have problems. Okay, Robert, all right, so yes, everybody has problems with those all the time. I agree. Is the line supposed to be from the upper right corner to the lower left corner? Tracy, honestly, it's just a matter of getting an overall, essentially, I guess you can call it analysis of the size of the part. And so because of that, it really doesn't make a difference. So if it goes from lower right to top left or lower left to top right, either way, the concept is just to get the overall size so it get that percentage in the percentage of the part, or the applied to the percentage of the part. Okay, Robert, yes, the tweak is in the older versions of the software. It is, what happens is once you define it, essentially you have those older drop-down menus. You will find it in essentially the menu manager, the very top part of it. Once you define the end conditions, you can do it through tangencies and continuous curvature and those type of things. If you go back up, you'll see tweak, and if you pick tweak, you'll really, honestly, you'll actually get the exact same interface that I just had in the older version. So they haven't changed the tweak interface, just kind of how you get to it. So the answer is yes, the tweak is in the older ones. Okay. Entire quilt at once. Can you select and paint an entire quilt at once versus having to select each element of the quilt? Let me see here. Mark, let me just make sure we're on the same page of what we're talking about. Okay. So are you talking about, let me open up, I can do it here, but let me open up something real quick. Merge. Okay. So, or what you're saying is, let's go ahead and view, clear all appearances. Okay. Are you saying that if I come in and merge these two guys off, let's just do a quick merge. We'll do a join. And then if I come in and say view, and we want to turn it red for instance, you can come down and say quilt, pick the entire quilt and do that. The way I usually do that though is by making sure I do it out of the selection filter. So if that's what you're talking about, the answer is yes. Okay. Hopefully that answers that question. Okay. Let's see. Let me get back to my questions. Okay. If switching to absolute, is there a good default value? Yes. Kind of like what I said here in the beginning, I will essentially live and die by this. I know that's a bad term, but essentially this is the right here is the accuracy that I believe that I have always had good luck with right there. Okay, that is the 0.0001. Okay, is the accuracy that I always use when I started doing surfacing work a number of different years ago. After just kind of reading some of the stuff, I have found that has always worked out well. That anything that I've always done. Okay, by default, this is the value within Creo/Pro E, but this is what I believe you should use right here. Okay, this is what starts out. That's the value you should use. Yeah, we are, Robert, good question. Just so you know, we always put our webcast actually on YouTube, so you actually can find these in YouTube. So at the end of the day here, or at the end of the session, what we'll do is you will get an email with the links to this webcast on YouTube. Sarah, can you confirm that for me?
Yes, that's
Sarah,
absolutely true. Yep, the links will show up. We should be able to encode it and get it posted this afternoon.
Okay, very good. And Tracy, the answer is yes, because there really is no separation between what is a surface model and what isn't. It's just the accuracy of your model altogether. So once you set that accuracy up, whether you're just doing solids or whether you're doing surfaces. It's just the accuracy of the model in general. So there really is no separation between the way the software looks at it one way or the other. Okay, so if you still have some questions, feel free to keep asking them. If not, at this point in time, it's just pretty much question and answer time. So if you have somewhere to go or have something to do, feel free to jump off. We won't be showing anything else when it comes to this. But again, if you still have some questions, feel free to ask them. I'll take them all the way up till the 1 o'clock Central Time frame. If you are hopping off, thanks for getting on. Hopefully you will attend some of our other webinars as they come up and things that you might find interesting. We are always doing these now on Thursdays. So again, you'll be getting emails, and feel free to hop on at any point in time. So. Again, if you don't have a question, feel free to hop off because we're pretty much done at this point. And thank you, Clint. Appreciate you for getting on. All right, it looks like there aren't any more questions. Again, thanks for hopping on if you're still there. I appreciate your time. Feel free to email me any other questions that you might have with the email address that you see up there. Thanks for hopping on, and I hope to see you soon.